This video is for Chapter 7, Section 4, about right triangle similarity. Before we start looking at right triangles and the similarity that we've been studying, we're going to take a little side tour real fast into something called geometric mean. At the end of this lesson, when we come into class, we'll see that geometric mean shows up in all of these problems and therefore can be used as a shortcut eventually. The geometric mean between two numbers is the proportional average between the numbers. You've heard of average, like the average between 4 and 6 is 5, or the average between 50 and 100 is 75. That kind of average is not this. Proportional average is the geometric mean between 4 and 9 is 6, because 4 is to 6 as 6 is to 9. The number 6 is proportional to 4 and 9 in that 4 over 6 equals 6 over 9. 6 is the number that is in between 4 and 9 and creates a proportion. So, if x is the geometric mean, here's our definition, between two numbers, a and b, then a over x equals x over b. And x will be in between a and b. It won't be right in the middle. It's not that kind of average. It's the proportional average. Now, if we cross multiply this, we see that x times x, x squared equals a times b. Some students take this shortcut. If I want the geometric mean between a and b, they just put x squared equals a times b. Take the square root of both sides, x squared is the square root of a times b. And in this case, we do not use a plus or minus because geometric mean, we only want the positive value that is in between the two. Here's your example. Find the geometric mean between 5 and 10. 5 over x equals x over 10. Cross multiply, x squared equals 5 times 10. Take the square root of both sides, so x is equal to the square root of 50. Break that down, 25 times 2, 5 radical 2. This was our little mini side lesson on geometric mean. A over x equals x over b. The first couple problems on this assignment have you do this. Okay, now let's look at right triangle similarity. This is where we'll just get into the lesson of this real quick, and you'll do a lot of problems in class. The figure to the left shows 3 right triangles that are all similar by angle. There's a small triangle, medium, and a big large one. They all share the same angles, but in order to see this, we're going to have to separate them. This line here is an altitude. It must create the 3 right triangles. So, each of the smaller triangles share 2 of angles. For example, here's the large triangle, 15, 20, 9 plus 16 is 25. Here's the medium triangle. Now the medium triangle has to be flipped around so that D is down here. 12, 16, 20. Now, this angle A is definitely in both of these triangles, and both have a right angle. Angle similarity. The small triangle, this is point B right here, unfortunately covered by the arrow. So we have 9, 12, 15. Both the large triangle and the small triangle share these 2 angles. Shared, right angle. They have angle similarity. Now these 2 don't appear to have angle, but we must remember that if 2 angles are congruent, then the third will be. If this is 90, this is 30, this is 60. 90, 30, 60. 90, 60, 30. So the point of this slide was just to see there are 3 triangles and they are all similar. Large, medium, small, all similar. Now, what we're going to do is we're going to organize our work. Sometimes the best way to solve things is to be organized. The side lengths of these this says similar triangles, can be organized in a chart to help us see the proportions of corresponding sides. Because if all these triangles are similar, they're proportional. So we're going to organize a chart. All three of these triangles have a short leg, a long leg, and a hypotenuse. The hypotenuse is the side across from the right angle. So, the small triangle down here has a short leg of 9, a long leg of 12, and a hypotenuse of 15. Medium triangle, short leg of 12, long leg of 16, hypotenuse of 20. And the large triangle has a short leg of 15, long leg of 20, hypotenuse of 25. Now, here are a couple things about this chart. You may not be able to write them down, but at least look. 1, the short leg is always across from the same angle. Forgot to mark these in right here. But remember, that's the same angle. The long leg is across from the same angle, and the hypotenuse is always across from the 90 degrees. Second thing to notice, these charts, very cool. They're 12, 12, 15, 15, 20, 20. And the line down the middle will always add up. 9 plus 16 equals 25. Now, right there is just a giant extended proportion. Let's pick any two corresponding sides from two of the triangles and we find a proportion. I want the short legs and the long legs of the small and medium triangle. Okay? 9 over 12 equals 12 over 16. There's a proportion for us. Corresponding short leg, 9 to 12. 9 to 12. Those are corresponding parts. 12 to 16, corresponding parts. Now, I can rewrite it, or I could simply just go like this. There's the proportion. There's another one. 16 over 20 equals 20 over 25. Here's one. 9 over 15 equals 15 over 25. All of the proportions we need are in this chart. If you check on your calculator, 12 times 12 is 144. 9 times 16, 144. Side note. Did you notice that 12 was the geometric mean between 9 and 16? 9 over 12 equals 12 over 16. Do you see that 16 over 20 equals 20 over 25? And 20 is the geometric mean of 16 and 25. The two are now connected. Let's do one example and be done. So now we're not going to separate the triangles. Instead, we're going to use the chart. Small triangle, medium triangle, big, large triangle. Here's the chart. In the small triangle, the short leg is 4, the long leg is y, and across from the 90 degrees is the hypotenuse. 4y, x. Medium triangle. This is tough. Is this the short leg? Is that the short leg? I don't know. Well, if y is the long leg of the small triangle, it can't be the long leg of the medium triangle because it's across from different angles. So, short leg, long leg, hypotenuse. Y, 9, z. In the big triangle, x is actually the smallest side, z is the medium, and 4 plus 9 is the hypotenuse. 4 plus 9 equals 13. Y, y, x, x, z, z. It always works out like that. Now, just pick a variable you want to solve for. I want to solve for y. There's no y in this column, and there's no y down here. Oh, there it is. I have solved for y. 4 over y equals y over 9. 4 over y equals y over 9. Y squared equals 4 times 9. Square root of 36 is 6. And yes, that was a geometric mean. There's another one. Using the short leg and the hypotenuse, so that's this column, and the small and large triangle. So short leg small over short leg large equals hypotenuse small, hypotenuse large. So, x squared equals 4 times 13. I'm not even going to multiply these together because the square root of 4 is 2, the square root of 13 just stays there. 2 rad 13. Take a quick look at z and we are done. Long leg, medium to large. Hypotenuse, medium to large. 9 over z, z over 13. Z squared equals 9 times 13. Don't even multiply them because the square root of 9 is 3 and 13 stays there. That's it for chapter 7, section 4. You can begin working on that assignment.